Okay, this is a lesson on variation, different types of variation, and once you get the hang of it, it's not all that bad. There's three different types of variation. There's direct variation, and it can be said in two different ways. They can either say y is directly proportional to x, or y varies directly with x. Okay, and the way that we would write that is y equals k times x. Now this k is called the constant of proportionality, or in some textbooks, most of the ones I've seen, it's called the constant of variation. Okay, and what that means is, for example, this could be a variation equation, y equals 3x. Okay, y varies directly with x, meaning it changes by a certain factor, in this case a factor of 3. Okay. Inverse variation gives us division. Y is inversely proportional to x, or y varies, whoops, that's a typo there. Let me fix that. Y varies inversely with x. Okay, so what you want to watch for is the language. If it says direct, you know you're working with the constant times the variable x. If it says inversely, you know you're working with the constant divided by that variable. Okay. And finally, joint variation is when you have more than one factor that's being multiplied. Okay, so y varies jointly with x and z means we have two different factors that are coming into play in the problem. Okay, so something might depend on your weight and your height, so you would need two factors there that are both multiplied. You might get a combination of these. There may be one that says y varies jointly with d and inversely with p. Okay, so you can have a combination, but again, you just want to watch for the language. If it says directly, you know you're going to multiply that by your constant of variation k. If it says inversely, you know you're going to divide your constant of variation by that letter. Okay? Let's do some examples. Okay, here we go. The amount in your paycheck P is directly proportional to the number of hours worked each. So again, what we want to look for is what type of proportionality or what type of variation we're given. And this one says it's directly, so we know we're using multiplication. So it says the amount in your paycheck P is directly proportional, and it told us to use K as our constant. Okay, and again, directly means multiplication, so directly proportional to the hours you worked H. So P, your paycheck is K times H, and we can probably guess that this K here would be the amount you make per hour. Okay, but that's pretty straightforward, an example of direct variation. The area of a circle A, okay, so that's what we're going to start with. The area A is, indicates an equal sign, directly, so we know what directly means. We're going to multiply here, proportional to the square of its radius. Okay, so directly proportional means I'm going to have my constant K here, and I'm going to be multiplying it by something. That something that they instruct me on is the square of the radius R. So remember, square means squared. The square of the radius would be written R squared. Okay, so we can kind of cut this end part out, and it's the circle area A is directly proportional to R squared. So our equation would look like this. A equals K times R squared. And if you've studied geometry lately, you would know that that constant of proportionality is pi, because area is pi R squared. Okay? But they just wanted a general form, and so that's what it'd be. A equals K, our constant, times R squared. All right, here's another we're asking to translate it into a mathematical equation and use K as our constant of proportionality. In kickboxing, the force F needed to break a board is, so that's where our equal sign goes, so F equals inversely, so again we want to watch for that, inversely means we divide by this new variable that's going to come into play, inversely proportional to the length L of the board. So we have our K inversely, it's going to be divided by L, the length of the board. So the force is inversely proportional to the length of the board. All right, here is another example, and you just, again, want to read through them carefully, highlight any key words. The weight W of a body is, okay, so W is inversely, so we know we're going to be using division here, inversely proportional to the square of its distance from the center of Earth. D is the variable they want us to use, and they wanted us to square that. So it's inversely, we're going to use division here, proportional to D squared, where D is the distance from the center of the Earth. So your weight is inversely proportional to your distance from the center of the Earth, squared. All right, here is another. The volume of a cylinder V varies jointly. So jointly, that gives me a key that I'm going to have more than one thing multiplied. That's what happens when we have jointly. More than one thing is multiplied by our constant K. So jointly with the height, H, so we multiply by H, and the square of its radius, R, so we have R squared. So the volume of a cylinder is K times H times R squared, and again, in the real life, that K right there is pi. Okay, so again, just read through it carefully, write it down as you go. All right, here's an example that I pulled off of purplemath.com because I was trying to find more examples. The thrust T of a propeller varies jointly. Okay, so again, jointly tells us right off the bat we're going to multiply more than one thing by our constant K. So far we know T equals K times something, and it's going to be two other things because of that jointly tips us off right there. Okay, so what's it going to be? Jointly with the fourth power of its diameter. So its diameter to the fourth power. Let me rewrite that. That's kind of an ugly 4. To the fourth power. And the square of the number of revolutions per second. And the variable they gave me for that was n. And they wanted the square of that. So here is our variation equation. The thrust is equal to K times d to the fourth times n squared, or is jointly proportional to the fourth power of its diameter and the square of the number of revolutions per second. Okay, like I said, sometimes you'll have a combination of the two, so just look through the question carefully. Here's an example of that. The number of candy bars C that I will eat, and this is sadly true, especially right now, the number of candy bars C that I will eat is directly, okay, so that means we're going to multiply by our K. Let's go ahead and put our K in there first to start off. It's directly proportional to the number of papers I have to grade, P. So it's directly proportional to P. And inversely, so we have inverse variation too in the same problem. Don't let you worry. All you're going to do is divide by whatever it says it's inversely proportional to. It's inversely proportional to the number of pounds I've gained in the last week, W. So we just divide by W. Okay, so that flick. Anything that's directly proportional would be multiplied by our K on the top. anything it's inversely proportional to would go in the bottom and be divided by that. Here's one last problem. This is where we use variation. Okay, so here's an application problem. It says the number of days D that it takes W women, so these are our variables they want us to use, to make Q quilts varies directly as the number of quilts and inversely as the number of women. Okay, so the first request is to write this as a mathematical equation. Well, fortunately, we know what directly and inversely mean. The number of days D varies directly with the number of quilts. So our constant K is going to be times Q, the number of quilts, and inversely with the number of women. So inversely means we're going to divide by the number of women. We have now answered part A. Mathematical equation would be D equals K times Q divided by W, where K is our constant, Q is the number of quilts, and W is the number of women. The next request they have is if 8 women can make 20 quilts in 6 days, what's the value of our constant of proportionality? Now remember, our constant is this value K right here. So what we're going to do is substitute all the other information they gave us. The number of days was 6, so D equals 6 equals K, we do not know, that's the one we're trying to solve for, times Q, which is the number of quilts, divided by the number of women, which happens to be 8. We're going to solve this equation to find out what our constant of proportionality would have to be. There's several ways you can do that, but we'll just go ahead and multiply both sides by 8 and divide by 20. We have 48 equals K times 20. Again, we're going to divide by 20, and then we'll probably want to reduce that fraction as much as we possibly can. Or you can probably, if you are more comfortable, you can write it as a decimal. Okay, so you just go 48 divided by 20, which reduces to 12/5. So our constant that we're using here is 12/5. If you want that as a decimal, it would be 2.4. Either one is just fine. Okay, part C says rewrite the mathematical equation from part A to include the value of the constant found in part B. So we're rewriting this equation, but we're replacing the K with what we found it was equal to. So we have D equals 12/5 times Q divided by W, or 2.4 times Q divided by W. So we took the original equation, replaced the K, because we now know what K is. And the last question says, how many days will it take for 6 women to make 50 quilts? So we use that equation we just set up and found. So D is 12/5 times the number of quilts, there are 50, divided by the number of women, there are 6 in this case. Okay, and then we just go ahead and evaluate that. So we do 12/5 times 50, which gives me 120 over 6, and 120 divided by 6 is 20. So it will take them 20 days to make 50 quilts if there are 6 women. Okay, so this is an example of where those proportional is used very often. We find a situation where we know the values, we find out how they're varying or what our constant of proportionality is, and then we use it to predict what might happen in the future or what we need in the future.